Alright guys, so this is the video where we're going to cover the last page of notes that we didn't get to in class. We're going to talk about the 5-number summary in this video. And the 5-number summary is a summary of a data set of medians. So first we're going to talk about the range of a data set. We're going to say that the range of the data set is the distance between the maximum and the minimum values of the data set. So right here, if we're looking at Roger Maris's home run totals, we have the greatest home run total is 61 minus the least home run total as 5. So right here we would say that the range of this data set would be 56 home runs. Right? There's 56 home runs difference between the least home runs he hit in the season and the most home runs he hit in the season. In general, we would say that the range is not resistant, which means that it's vulnerable to outliers. If we look at the range without that 61 home run season, we would say that without 61, our range is 39 minus 5 or 34, which is a big difference from that 56, right? So range is telling us about the difference between the smallest piece of data and the largest piece of data in our data set, but it's not necessarily going to give us a good idea about the overall data if we have a really large outlier like that 61 home run season. We'd say that the interquartile range is the range of the middle half of the data, and it's more resistant to outliers. And so we're going to talk about how we get that interquartile range. Right here we've got Roger Maris's home run totals again, and what we're going to do is we're going to come up with the median for this data set, and then we're going to come up with the median for the first half of the data set, which we call the first quartile, and the median for the second half of the data set, which we call the third quartile. So right here, if we're looking at the median, we say the median is the middle number from a list of numbers arranged in order from least to greatest, we can say. Here we have two middle numbers, 16 and 23, and so our median in this case is going to be the average of those two numbers. So we'd say our median is going to be 23 plus 16 divided by 2, and that's our 19.5, right? Now right here, when we're getting the median for the first half of the data set, or the first quartile, we're going to do the exact same thing only just for the first half of the data set. So we're going to take our middle two numbers for the first half of the data set, and that's going to be our 9 and 13. And so right here we would say 9 plus 13 divided by 2 gives us a first quartile of 11. Now right here we'll get our third quartile by taking the median of the second half of the data set. And right here we've got two numbers in the middle of that second half, 28 and 33. And so we would say that the third quartile would be 28 plus 33 divided by 2, which is 30.5. So right here, to determine our interquartile range, we are going to take the difference between our third quartile and our first quartile, and that's going to be basically the middle half of the data, the half that goes from the first quarter of the data to the third quarter of the data. So right here we would say that our interquartile range in the case of our Roger Maris home run totals is going to be 30.5 minus 11, or 19.5. And it's just a coincidence that this happens to be the median. That's not always going to be the case. So right here we would say that the 5-number summary is the min of a data set, the first quartile of the data set, the median of the data set, the third quartile of the data set, and the max of the data set. So right here for Roger Maris's home run totals, we would have the 5-number summary as 5, 11, 19.5, 30.5, and 61. We can graph the 5-number summary with what we call a box plot. So right here, a box plot is basically going to plot these 5 numbers, right? And then it's going to draw lines connecting these 3 numbers with a box around the interquartile range, and a line in that box to denote the median. So right here, our box plot would look like this. We would have 5, we would have 11, so a little bit past 10. We would have 19.5, so just short of 20. and then right here we would have 30.5, so just past 30, and then we would have our 61 way out here. And right here we would have two lines connecting the min and the first quartile and the third quartile on the max. And then right here we would have a box around the interquartile range. And right here we would have a little line in that box denoting the median of our data set. So right here, this is just a way for us to visualize the 5-number summary. We can get the 5-number summary from our calculator if we go in and enter our data in L1, right? So here are my Roger Maris home run totals. I can go to stat, over to calculate, and then that list of numbers that I get from one bar stat is actually going to also give me the 5-number summary. So right here, I can press enter on one bar stat, and then I'll press enter on L1, that's where I'm taking my data, press enter on frequency list, enter on calculate, and then right here, I've got my min and my standard deviation right there. And if we keep on arrowing down, what we're seeing is the min of the data set, the first quartile, the median, the third quartile, and the max. So there's our 5-number summary. We can also get the box plot on our graph. So right here, if I go to second and then stat plot, I can press enter on plot 1. I can turn plot 1 on. And then if I go down to the depictions of my data, if I go all the way out to this guy right here, which is the box plot, I can press enter on that guy, and it's going to take the data from L1, which is what I wanted to do. Now right here, if I go to zoom 9, I'm telling my calculator that I want it to zoom in on a window on the XY axis that will show me the entire box plot, and there's our box plot right there. Now right here, if we press trace, we can actually get the calculator to give us the median, the first quartile, the min, and then if we arrow all the way to the other side, the third quartile and the max by arrowing back and forth, right? So we can actually sort of see those pieces of data on the box plot itself. Now, right here, we say that a technical definition for an outlier is any piece of data that is greater than 1.5 times the interquartile range away from the first quartile or the third quartile. So right here we would say that we have an outlier if that number is greater than the third quartile plus 1.5 times the interquartile range, or if we have a piece of data that is less than the first quartile minus 1.5 times the interquartile range. So let's test to see if that 61 home run season is actually an outlier. Right here, we would say that this number for Roger Maris's home run totals is going to be 1.5 times our 19.5, which turns out to be 29.25. Now right here, we would expect to see that outlier of 61 home runs be greater than the third quartile plus our 29.25. And right here we can say that 61s is actually greater than the third quartile, which is our 30.5 plus our 29.25. We have 61 as greater than our 59.25, right? So that means that in terms of outliers, 61 meets the technical definition of being an outlier. We can actually represent the box plot with an outlier, with a modified box plot. And right here we can see that if we go back to stat plot. Right here, if I press enter on stat plot, now right here, if I go over to the picture right before our box plot, we'd call that a modified box plot. Press enter on that. And right here now, when I go to my graph, I'm seeing my 5-number summary as basically having a min of 5 home runs, a first quartile of 11 home runs, a median of 19.5 home runs, third quartile of 30.5, and we're taking 39 as the max, and we're seeing that 61 home run season as the outlier, as an ordered pair outside of the box plot, or that modified box plot. All right, guys, so this video covers everything you're going to need to know for question 23, and we'll talk about this stuff more in class on Monday.